Hello everyone. Another video with another examples related to kinematics equations or motion in one dimension. In this video, I will be focusing about an object moving on the x-axis under a constant acceleration as I described on the previous video, where the kinematics equations can be used or can be valid if I have an object moving in a constant acceleration on one dimension. Okay, so uh, in this example, I have David is riding the car to his hometown. If the car starts from rest and accelerates at a constant rate of 10 meter per second square. That's great. So what I have here, that's the constant rate, and the unit is for the acceleration meter per second square. So that's perfect. It is a constant acceleration. The car's top speed is 150 meter per second, and the question is, how long does it take for the car to get up to the top speed? Okay, so what I have here, it is always good with these equations or these questions to sketch, even a simple sketch or draw to help you visualize the scenario. So David is riding to his uh, hometown. So let's assume this is the starting wherever it was. He was, that's the initial position, and he's going to his hometown. So he will be traveling a certain distance. That's the distance he will be driving or riding his car. Anyway, what he's mentioning that when he started from rest. So the initial velocity is 0 meter per second. He was accelerating in an average rate of 10 meter per second squared. And we know for sure that the maximum speed within this strip can be 150 meter per second. Now, the question looking for how long does it take David to get to his hometown, or sorry, to get to the top speed of his car? How long does it take from starting from 0 to 150 meter per second? So when we think about what is known of these variables in the kinematics equations and what is unknown, I think it is always, if we try to have them, if you have these kinematics equations printed on a sheet outside or you have it on beside you, you will find that if I apply that V final equal V initial plus acceleration multiplied by the time, it will be the good equation to use, because I know that the final speed is 150. That's our aim. Now the initial was 0. Now acceleration already given, it's a 10 meter per second square. The time is the only thing we don't know. Just by rearranging the formula, it's 150 divided by 10. That will give me a 1.5 seconds needed for him to reach this top speed. It's quite really short time to hit from 0 to 150 meter per second. Okay, so that's the way. Again, remember, with the kinematics equation, always need to remember I must have sorry, constant acceleration. Try to sketch the scenario, put the variables, what do you have, what you don't have. If something not needed, like the distance he traveled, it wasn't important in this scenario, uh, so I can ignore it, and then I will pick the right kinematics equation to help me solve this problem. Okay, let's go to another example. I have a shuttle bus, slows down with an average acceleration. Again, it's an average acceleration, so it's kind of like it's a constant, we can say. With this acceleration, it's 1.8 meter per second square. How long does it take the bus? how long? Again, we're asking for time, the bus to slow down from this velocity to stop or to complete stop. So this is the initial velocity. That's the final velocity. Now, in this case, we have to pay attention to few things. When I say the bus is slowing down with this acceleration, this means this acceleration, in fact, it's a minus 1.8 meter per second square. It's showing me it's a decelerating. The word slowing down, it's alert me that this acceleration, it's a negative, it's decelerating. Okay, so again, I have these information, these the variables I have. Let's find out which equation could be the really good one. Again, I have v final, v initial, acceleration, and time. There's no need to think about how far did the bus travel. So I think it's the same like the previous example. It's v final plus at. Now to stop, that's 0. The initial was 9 meter per second. Here is negative 1.8 and t. Now just simply that's the 1.8 t equal 9, and t will be, just to be sure, nothing else. So it's gonna take the bus 5 seconds to stop completely, or to drop the velocity from 9 to 0 meter per second. Okay, once again, this is the way to handle kinematics equations for a motion in one dimension. Know what's your variables, what do you have, what is missing. Think about the words being used, like here, the slows down acceleration means it's decelerate, so I have to have a negative value or put the negative sign. Pick the right equation from the kinematics equation, and then it will be just simply doing the calculations. Okay, I hope you find this video useful. I'll see you with another video with different examples. Thank you.